So SDL3 was released, and this is very nice because it's of course new version of the beloved library. And what I'm interested in is actually this new feature called GPU API, which is kinda similar to what Sokol provides, for example, which is a abstracted multi-platform but still very low-level access to the GPU graphics and computing API. And there was also a new release of Odin that actually includes the vendor bindings for SDL3. So let's actually try that. Let's draw a triangle and then maybe some more in Odin and SDL3. So let's go. Make dir, hello SDL3, of course. Code, hello SDL3. Let's get started. So here I have my empty project. Let's create an Odin file. Let's give it a package, something like main. Let's say I want to import SDL from vendor SDL3. That's nice. Let's say main, which is a procedure. Let's maybe set up some logging, import or log. Let's set some defaults like context logger. Let's just create a normal console logger, the usual things. So like this. Now log back. Hello. Hello. So let's start with a build.bat file. Very simple. Odin build here minus debug. And if we wanna run, what's the syntax again? Keep forgetting, like this, right? If you wanna run, then just run it like hello SDL3.exe. So now we can set up the task for VS Code. If you use the other editor, that's of course up to you how you set it up, but I'll keep things very simple. Now it's just say build.bat and run. So yes, that should be it. Yes, we want to configure it by default. And yeah, here it is. So let's start with SDL then. So first thing what we want to do with SDL is of course call SDL init. And here we pass whether we want a video subsystem or some other events are enabled by default, so we don't really need to specify them, but video is something that we need. And if we do that, Odin will already complain about that it requires results to be handled because, well, this, right, require results. And this mainly a great practice because you want to handle errors. So you could do something like okay, right? And if not okay, then I don't know. For example, you could panic with could not load SDL or rather init SDL. And here you could also pass an error from SDL, get error, and you will get a pretty nice panic message. I don't want to really pollute the code here with all this error checking because that's really up to you how you do it. So what I will do is simply assert that it was okay. And here our SDL is initialized. Now we want to create a window. So that would be a SDL create window, of course. Here we just apply a title, hello SDL3, 3, and some size like, I don't know, HD, right? And some flags like full screen, if it's resizable or not. Let's not really care about that. For now, we can say assert that window is not nil. And that should already give us a window that will briefly show up, and that's it because our application quits immediately, so there's nothing. So let's just create a main loop, like main loop, and inside the main loop of our game we wanna process events, right? Update game state and render. So processing events in SDL is very simple. It's very straightforward. You just say event, which is a structure of SDL event, and then you say while, well, for SDL poll event. So while this function returns true, we have some events to actually check, and that needs a pointer to our structure to fill. And here we can do already a very simple partial switch for by event type to, of course, handle the quit. So we actually partial switch, I'm sorry, to handle the quit event. To when we close the window, we want to also close the application, so we just break from the main loop. That's why I actually added a label here, so we can break. And now we have this window, and it's not going away unless we click this. Let's maybe also add a key down handling quickly to close the window with the escape key. So if the key scan code is escape, then just do also break the main loop. So far so good. Now we don't really want to update the game state because we don't have any game state. What we want to do is render something because we are interested in the GPU stuff, right? And to do that, we need to do some more initializations. For example, we need to create a GPU device. So let's just call it GPU and say SDL create GPU device. Here you need to supply a shader formats that your device will use. Well, SDL3 supports stuff like SPUR-V or DirectX or Metal shader formats. So SPUR-V is the Vulkan one. So this is what we're gonna use. You can specify multiple of them, and then it will choose the best kind of. You can also specify which one to try to choose with this name argument, but this not we are gonna do. Let's say that we want to debug. That will enable some validations, which are very handy if in case we make errors with pipeline structures or shader or whatever. And this can be nil. So as I said, this name is a selector. You can specify like Vulkan, so it will prefer Vulkan or DirectX. I never used that, but it's there, and you can actually check the documentation. It's really good. This whole documentation, really, SDL3 is very well documented, so kudos to them. And you can just check the documentation for some particular function. You see the preferred GPU driver or null to let SDL pick the optimal driver. So this is what we're gonna do. And here it also actually described the flow, how the rendering should work. So this is what we're gonna recreate. So after creating the GPU device, we want it to claim the window. So we are gonna be rendering with the GPU API and not something else. So we need to claim the window for this GPU device, and this is what we're gonna do. Maybe we also just assert that GPU is not nil, and we will say GPU claim window for GPU device. So we just say our GPU to this window, and we can say also assert that everything is okay. So now basically it is set up, and what we want to do is draw stuff. And to draw stuff, it's a bit more complicated than it is in Sokol, for example. So it's a bit low level. It's more closer to, well, Vulkan actually. And how you do this is that you first acquire a command buffer. Then you acquire a Swapchain texture. Swapchain texture is basically a texture that will be presented on the screen. Then we begin render passes, draw stuff, and render pass. Well, actually, we just begin one render pass, we draw stuff within that render pass, we can do more, and after that we submit the command buffer. So commands are, well, actually commands that you pass from the CPU to the GPU. So yes, this is all represented in the SDL API. So first we, of course, acquire the command buffer, and this is exactly the function name, I believe. SDL acquire GPU command buffer. So we pass the GPU there and we get the command buffer. So this is done. And also we want to submit the command buffer. So we say SDL submit GPU command buffer. Just we pass the buffer that we created, and it also returns bool, so we can say okay, and maybe also assert that it was okay in fact. So that's done. If we run, nothing will really change because we are not drawing anything. So first what we want to do is acquire the Swapchain texture, and for that if we take a look again at the API, if we search for Swapchain, so rendering can happen to a texture what other API call a render target, or it can happen to the Swapchain texture, which is I just described, which is special textures that represents window contents. The app can use wait and acquire GPU Swapchain texture to render to the window. This is exactly what we are gonna use. So SDL wait and acquire Swapchain texture. So the signature of this function is that it returns bool if it's successful or not, and it fills those pointers that we give to it. So it gives us a texture and also the width and height, but we can pass nil there if we don't care, which we don't for now. So let's do this. We pass the command buffer that will be assigned, that will be well connected to the Swapchain texture, the window, and then the pointer to the Swapchain text, which would be our new variable here. Let's say that would be just a variable uninitialized, which is a pointer to SDL GPU texture. So that's basically just a normal texture, and this one can be nil, and of course we can just assert that it was okay. So now we have the texture. This is done. Now we can actually try to draw things. So how do we draw things? Well, we need to create a render pass, begin render pass. We set the GPU, the command buffer, so we pass it to it. Then we need to supply it with the targets where we want to draw. The most important thing is, of course, color target. Where do we want to draw colors? So we want to draw to the Swapchain texture, so this is what we're gonna provide here. We can draw to multiple targets, but we're gonna only draw to one. And for now we don't really care about any depths or stencil settings, so this can be also just set to nil. So let's say color target, that would be a structure that we will define shortly. It's only one color target, and this can be nil, and this would return a render pass to us. So the color target is just a very simple description structure, SDL color target GPU color target info, this one, right? And now if we take a look at what it actually contains, is the target texture that will be used as a color target and some more settings. So for now, let's just set this one. So texture is our Swapchain texture. Mip maps and layers, we don't really care. What we care about is what do we do with this target. So first we want, when we are loading it, we want to clear the contents. So let's say the load op is clear, and we can supply the clear color, which would be something like, what would be a pleasant color? Something like maybe greenish blue, something like this. Then we need to provide a store operation, like what to do with this picture that we rendered, and we wanna of course keep it for display, so we need to specify store. We actually don't really need to specify it because this is a default 0 enum value, but just to be explicit we want to do this, and everything else is something that we don't really care for now. And of course we need to actually end the render pass. So we did the begin render pass, and now we want to end the render pass. So SDL end render pass, and here we just say render pass. So yes, if we want to do more rendering passes, we can do that, but for now we will not. So the only thing that is left is actually drawing stuff, but let's run and take a look at our very nice blue color. Okay, that was nice. So now what we wanna have is drawing things. But actually before that, I wanted to show you one more thing that you can do with SDL for debugging, especially that would be helpful, is that you can specify the logging level, which would be a function called set log priority or set log priorities to set one priority for every module, and we can set it to verbose, for example. Now if we run it, we will get some debug information, and this is the default logger, but you can also specify your own logger, like for example to use the normal Odin log function. So we can just say SDL set log output function, which would be this callback, which would be this procedure, right? And we can just copy paste this and put it here and just fix the prefixing for SDL stuff. And we can also pass some user data, and this is something that we want to do because we want to have a context, which would be context. Actually, we maybe can avoid even passing it as a user data, because we can just store it as a global variable like I did with the Sokol video. So for that, we of course need to specify a type of the global variable, which would be of type base runtime and runtime context, and we just set it not as a local variable but as a global one. And here we can, because it's a C procedure, it doesn't have any context, but we can just use the current context from the variable that we set before, and here we can just do something like log debug f. Of course, we should probably handle the priority and see if it's a critical error or warning or error, and use different logging functions, or maybe there is a function to just log with a level. So this is something that we can do, but for now let's just pass everything to the debug function and say SDL, maybe the module name or other category name, and then priority name in square brackets, and then the message. So we say category, and then priority, and then the message. So now it will look somewhat like this. I mean, this is a bit annoying that we will have this location information. Too bad that SDL doesn't support providing location information. So like, for example, Sokol somewhat supports it. That would be nice to get actually localized errors, but there's no nothing passed for that. So, but I would say that's good enough for now. So let's now start drawing something. So to draw stuff, we need a shader, right? And unlike Sokol, SDL doesn't provide you with a standard shader compiler. It's not really opinionated. You can load shaders of different formats like SPERF or MSL or DXL or whatever, because there's support for multiple ones. You can see what it supports here, right? Metal or DXL, MSL, SPERF. We will use SPERF, but even the SPERF is a bytecode, right? And you need to compile the shaders from some language to the SPERF bytecode. And you can use either GLSL or HLSL, which are the two most popular ones. And for that, you need a shader compiler. That is something that you will have to install. Now you have multiple options. The easiest one that I will use for this video would be to install the Vulkan SDK. Well, Vulkan SDK, right? Like this. And you can just download it from this Lunar Exchange, for example, right? You just download, install it. It's very straightforward. I don't remember if it adds itself to the path variable or not, but I have it here. So I, for example, have this program called GLSLC, which is here. You can request some help for it, or you can actually check where is it, which So if you can see, I have it installed here in the Vulkan SDK. So this is something that we're gonna use to compile our shaders from GLSL to Sphere V. I don't know how it's called, Sphere 5. You could also use HLSL, which is of course the Microsoft DirectX first kind of language, which can be also transpiled to Sphere, and for that you could call DXC, right? I even have some command line here, and it's actually also provided with the Vulkan SDK, so you can use both. That's one option. Another option is actually SDL provides something called SDL shader cross. No, that's the Odin bindings, I'm sorry, but this is the actual library, SDL shader cross, and it's not available as a binary release, so you would have to actually build this, and I managed to do this, but it was not easy, at least on Windows, because yeah, it would require you to actually install Visual Studio, which is not Visual Studio build tools, but like the actual full Visual Studio, and then you would need to install some additional libraries like Windows Driver Kit and stuff, and then you can compile it. That would be an exercise for the viewer, I guess. Maybe I will create a video about this, but it's not very complicated. You just need to set up all the compilers and whatnot. But this tool is actually quite nice because it compiles together with all the DirectX and Sphere libraries and whatnot, and it can just take HLSL sources and output it for all the supported destination formats like Sphere or DXL, and it can also export you JSON with some reflection information that could be useful. But yeah, as I said, I will not use this for now. We will just do with the simple GLSLC, and this is what I'm gonna use. Mostly actually because I'm not really very comfortable with HLSL, which I should probably fix. Let's just write a very simple shader called, well, we need two shaders actually. We need to create a fragment shader and a vertex shader for two shader stages in the pipeline. So let's do that. Let's start with that. Let's call it shader.glsl.frag for the fragment shader, and then also shader glsl.vert for the vertex shader. And yes, VS Code being quite slow. And yeah, let's write a very basic GLSL shader, right? We need to specify a version of something. I think this is the last one, and then we can say main. And in the vertex shader, we of course need to set the position. And let's not do this for now. Let's just have actually the same in the fragment shader. And what we want to do is to make it compile. So let's, as I said, we're gonna use GLSL, so GLSLC. If we take a look at the command line help, we'll see that it has a lot of options, and it wants you to provide the file. And I think if the naming is right, that is actually everything that you need for now. So let's do exactly that. GLSLC shader glsl frag, and that will compile to the Sphere file, but it will compile to the a.spv, which is, well, not something that we want. So we want to specify the output as well. That would be the shader spv.frag, right? That seems to be working well. And we do the same with vert. So let's just put this in our batch file to keep things very simple. We could maybe make a better batch file or use some build system, but yeah, this is fine. We are not gonna do this for now. So now we wanna load those shaders actually and build a pipeline for rendering, because how rendering happens is that inside the render process you bind pipeline, bind vertex data, and you bind uniform data, and finally you do the draw calls. So to be in the pipeline, you need a pipeline to be constructed, and for that you need shaders. So let's do exactly this. So to create pipeline, we of course want to do this before doing the main loop. So we say pipeline equals SDL create GPU pipeline, and namely graphics pipeline specifically. That would require us to pass the GPU device and then just to create information, which is a structure as usual with some information that we can pass. And let's see what is important here. So we need a vertex shader and fragment shader, that is for sure. We just created them. Then we want to set up the primitive type, which would be by default a triangle list. So that would be fine. But maybe we can be a bit explicit and let's set this to nil for now. And maybe we can say triangle list, because yes, we want to draw a triangle. The rasterizer state is about the filling and color modes, which is something that we don't really care about. We can leave it as defaults. And then the target info is another very important part of it, is the information about the target where we want to draw using this pipeline. And that is related to the render process. So you see we have the color target information here and we specify the texture, but the pipeline wants to know some more information about the texture that we're gonna pass. And since we are not doing any depth and stencil information, the only thing that we really care about this is the color target. And the main thing that it wants to know is the format of the texture that we will draw to. So let's basically specify the num of the color targets, that will be just one. So for the color target descriptions, we need to specify an element, or rather a number of elements that we want to give to it. So since we are giving it just one, we can simply make the following. We can specify a pointer to just one value of SDL GPU color target description, and that needs a format of our Swapchain texture, which we can get with SDL get GPU Swapchain texture format for given device and given window. So there's this, and now we wanna create the shaders, the vertex shader and the fragment shader. Actually, we don't want to create them because they are here. We just want to load them from the spur format, which we specified here. So what we do for that is, of course, we just say SDL create GPU shader, and that needs a device, which we have, and the create information. So if we take a look at the create information that it needs, that is all the code, the entry point name, which would be our main function, which format it is, which would be spur v, that we only care about for now, and the stage, and then some information about how many samplers do we pass, or storage buffers, or uniform buffers, which we will not pass for now. So let's just think, how do we want to load the code? And the easiest thing in Odin is actually just to embed it into the binary directly, which we can very easily do with something called pound load, and we can specify our shader name like this, right? So this would be our fragment shader, and then we have the vertex shader, and we just say shader code equals, and then we just say it's either frag or vert. So this will give us a slice of bytes, which we can directly use here. So the code size would be simply a len of, well, let's say we are creating the vertex shader, right? So just vert shader like this, len of the vert shader code. And for the code, we want to specify just a pointer to the raw data of vert shader code. So the entry point would be, of course, our main function. Then the format is spur v. By the way, this is a bit awkward because the bindings for the SDL GPU shader format enum is actually not really an enum, it's a bit set, which is used here. For example, when we set up the GPU device, we can set multiple bits for different formats, but it's also used for the format which can be just a single value. But since there is no specific enum with the actual values of these bits, it's also specified as a bit set in the create GPU shader function signature, or rather in the create info, which means that we want to actually pass the bit set, and for that we need to specify this curly braces. It's a bit awkward, but just make sure that you don't specify multiple bits here, and you're gonna be fine. It's not a big deal. Anyway, so we specify the format, and now we need to specify the stage, which would be our vertex shader. So that would be our vertex shader. Maybe we could already extract this into a function like load shader. I'm sorry, in a procedure, of course, that would return a pointer to SDL GPU shader, because this is a type that the create GPU shader returns. So yes, that would need a code that we pass, right, which would be just a slice of bytes, and then the stage, which would be SDL GPU GPU shader stage. For now that should be fine. We can just replace this, and the stage would be this. And now we can simplify our loading with just a very simple function call, procedure call, vert shader code, and then this would be our vertex, and the fragment would be our fragment, and of course that should be frag, this should be frag, and here we just pass them like this, right, the vertex and the frag shader. And by the way, after creating the graphics pipeline, we can already release the shaders, because it's basically once the pipeline is created, we don't really need to hold the shaders anymore. So it's a good practice to just call release GPU shader already here, GPU and vert shader, and of course the frag shader as well. Yes, so now we have the pipeline, and we can actually try using it. Of course I have some problems here, namely here I forgot to pass the GPU device. Let's call device here, and device would be a pointer to SDL GPU device, right? And now we want to pass it here, of course, just here we call it just GPU. So now if we run it, we get the program running and compiling fine. And now we want to draw stuff, so we need to bind the pipeline, SDL bind pipeline, graphics pipeline. We bind it to a render pass, and we pass the pointer to the pipeline, which is our pipeline, of course. So we don't really have any vertex data or uniform data. We don't really need to do this for the very simple and basic triangle, because we can handle it all in the shader. And what we want to do anyway is draw GPU primitives. The very simple function would be, of course, just draw a triangle in this render pass, and triangle is 3 vertices, 1 instance, first vertex and first instance. Those are offsets that we don't care, so we set it to 0. So now if we try running it, nothing will happen, because our shaders do exactly nothing. So let's fix that. So the fragment shader is of course very simple. We need to just specify a out color, which is of course of vector 4 color, and you also need to specify the explicit location of the output. That would be like this, and color, let's make it just red. That's fine. Don't forget the semicolons. It's not Odin. It complains. Oh yeah, it needs to also have the out specifier like this. And by the way, yeah, because we are using the simple batch file, that will ignore any error code, so maybe it's a good idea to say if error level not 0, then just exit the batch already here, just do it here like this, so the program actually doesn't even proceed to compile if the shader is broken. So this would be our fragment shader. Now for the vertex shader we can do something very simple, because we send the command to draw 3 vertices, and the shaders have this special variable called vertex index, and we can decide actually which position to set depending on the vertex index. So this is what we're gonna do for the very simple triangle. Remember the coordinates here is in the clip space, so that would be from -1 to 1 in each direction, and 0 will be at the center of the screen, so we can use that information to actually position our vertices. So let's say if GL vertex index, if I remember correctly, maybe it's vertex index with, no, I think it's like this, right? So if it's 0, then the position will be -0.5, and then, so that would be our bottom left, and that would be maybe like this, right? -5, Z is 0, and W is of course 1. So yeah, the first vertex with the index 0 will be at the bottom left, then the second one will be at the top center, and the third one with index 2 will be at the right and bottom. So if we run now, we will see a perfectly red triangle, which is a good start. Yes, one more important thing is that the Swapchain texture can be actually null. For example, if the window is minimized, and you always have to check for null before drawing anything, because like if you supply the null here, it will crash and burn. So let's simply wrap our whole rendering code with a Swapchain null check. So if Swapchain is not nil, then, well, we need to do this. Oh man, I should really learn to edit in some proper editor, but this will do for now. And I can actually show you how this works. So if we say look debug here, and let's say rendering, and whoops, we don't need a semicolon, and else we can say yes, not rendering. And now if I run the game, we will see it's rendering, but if I minimize the window, it's not rendering. And yeah, so that's one important thing that I forgot to add, and but I added it now. So in the second part we are gonna look more in actually supplying vertex data like mesh data and uniforms and matrices and whatnot, so stay tuned, I guess.